So for this function, we have a little bit more work to do than we did in the last one. First of all, we notice that the equation is not in the form y equals a times cosine of b times x minus c plus d. It's not in that form yet, so we have to put it in that form. All we have to do is factor out cosine of 2. Okay, so we have to factor out a 2, right? So the easiest way to do that, first of all, if you factor out a 2 from 2x, you just are left with x. But if you want to factor out a 2 from pi over 2, the question is, well, how do we do that? There's no 2 up there. There's 2 down there, but that's not the 2 we're factoring out. We're factoring out a 2 from the numerator, so let's put a 2 in the numerator. And if we're going to put a 2 in the numerator, we have to also put one in the denominator. So now we have a 2 to take away from that term. And if we take a 2 away from that term, just like we took a 2 away from the 2x, we're left with x. And if we take a 2 away from 2 pi over 4, then we're left with pi over 4, and that's a plus. Okay, so if it's a plus, we're gonna also, I hate to do two steps at once, but if that's a plus, we're subtracting really, we want to put it in this form, x minus negative pi over 4. Now, if you don't want to do that, that is totally okay. In fact, that might even be more confusing than just taking the 2 out and just leaving it as x plus pi over 4. Maybe we could just leave it like that. So either way, this is just telling us that we're going to move pi over 4 radians to the left. All right, so we're going to, when we get to that point, when we shift it left or right, we're going to move pi over 4 radians to the left. And we kind of know that anyway, like all those transformations that we've done all year long. We know that if there's a plus sign there, whatever follows the x, if it's a plus, then we know we're going to move left, pi over 4. Okay, so we're going to keep that in our back pocket for now, and we're going to graph this function as if it's just y equals, it's a bad equal sign, y equals cosine of 2x. That's what we're going to do first. And so let's first decide or determine, well, let's actually just follow the steps. So get the equation in the above form, check. Find and plot the period, 2 pi over b. So the period is 2 pi over b, and in this case, the b value, unlike the last one, which was 1, the b value is 2. So the period is 2 pi over 2, which is just pi. We found it, now we have to plot it. And again, we're going to be moving pi over 4 radians to the left, so let's kind of do some pre-planning here and move our y-axis a little bit further to the right to leave us some room to move this the graph of this function to the left. And now we can go all the way out here. Again, the period is pi, so we're going to plot that. We cut that in half, pi over 2, and then we cut that in half, pi over 4. Halfway between 0 and pi over 2 is pi over 4. So each little subsection of the entire period is pi over 4 radians. So we go 1 pi over 4, 2 pi over 4, and 3 pi over 4. So if you remember the little trick of multiplying the first subsection number by 3, you get the third one. All right, so that's step 2. Divide the period into 4 equal sections. That's step 3. Draw the midline, y equals d. Again, the d, there's no plus anything out here, so the d is 0, so the midline is already drawn for us. It's the x-axis. And then find and label the amplitude. Now the amplitude, again, is, I'm trying kind of getting into my graph here. So the amplitude would be the absolute value of a, and the a value is 1. It's the coefficient in front of the cosine. And so that's just 1. So just like the last graph, we had an amplitude of 1. Distance between the midline and the high point. Distance between the midline and low point. That's our amplitude. And then draw the sinusoidal graph without shift left or right. I forgot to mention on the last graph, why did we start at 0, 0? We started at 0, 0 because it was a sine graph. And this particular graph is a cosine graph. Still sinusoidal because it's going to be kind of going back and forth, a little wavy line. That's a sinusoidal graph. But the cosine graphs start up here at 0, 1, and this is no different. This is a cosine. So again, we're graphing cosine of 2x, and we're going to plot the 5 points. Up here, the high point is where the cosine starts, and then when you're at the high point, the next subsection, subinterval I should say, would be pi over 4. From the high point you go to the midline, then you go down to the low point, then you go back to the midline, and then you're back to where you started. So if this were just cosine of 2x, it would look just like this. That's the cosine of 2x. But remember, we're holding off on shifting the graph. And we already talked about shifting the graph to the left pi over 4 radians. And so that's our last step. This is a nice one because already the subsections or the subintervals are already sectioned off in pi over 4 radians. So all we have to do now is take the 0 and subtract pi over 4 radians and move that high point, that starting point up here. We're going to move it to the left pi over 4. The midline then, or the midpoint, moves to the left. All the points move to the left pi over 4 radians on the actual graph of the given function. And then back to the midline again, and then back to the top. So the actual graph of y equals cosine of 2x plus pi over 2 for over one period looks just like that. And there you have it.